Transfer learning. Reusing pre-trained models. If deep learning is the engine of artificial intelligence, then transfer learning is the shortcut that allows AI to learn faster, with less data, and with greater efficiency. Imagine if every time you wanted to learn something new, you had to start from scratch, relearning the alphabet before writing an essay, or memorizing basic arithmetic before tackling calculus. That would be absurd, right? Humans build on prior knowledge. And now, thanks to transfer learning, so does AI. This concept has revolutionized machine learning, unlocking capabilities once thought impossible. It's the reason why AI can diagnose diseases, translate languages, generate art, and recognize speech, all without needing millions of examples for every new task. In this lesson, we'll explore how transfer learning works, why it's so powerful, and the real-world breakthroughs it has enabled. The old way. Why traditional AI training is inefficient. Before transfer learning, training AI models was brutally inefficient. Every time a model was built for a new task, it had to start from scratch, requiring massive datasets, excessive computing power, and weeks, or even months, of training. Take image recognition as an example. Suppose you wanted to build an AI to detect cats in pictures. You'd need to collect thousands, if not millions, of labeled images. Train a deep learning model from zero. Wait while it painstakingly learns to recognize basic shapes, then fur patterns, then finally entire cats. Now, imagine you wanted to train another AI to detect dogs. The process starts all over again, new dataset, new training, new costs. This is how AI used to be developed, reinventing the wheel every single time. But what if the AI that learned to recognize cats could transfer its knowledge to also recognize dogs? What if instead of training from scratch, it could adapt an existing model, one that already understands edges, textures, and shapes, so that it only needed a little fine-tuning? That's exactly what transfer learning enables. How transfer learning works. AI that stands on the shoulders of giants. Transfer learning allows AI models to take knowledge gained from one task and apply it to another, related task, just like how humans build upon past experiences. Instead of training from zero, we take a pre-trained model and adapt it for new purposes. Here's how it works. 1. Pre-training on a large dataset. A deep learning model is first trained on an extensive, general-purpose dataset. This could be ImageNet, millions of labeled images, for vision tasks. Common Crawl, huge amounts of web text, for language models. Massive speech datasets for audio recognition. During this phase, the model learns broad, foundational knowledge, basic shapes, object structures, linguistic patterns, or speech phonemes. 2. Fine-tuning for a specific task. Once pre-trained, the model is fine-tuned on a smaller, task-specific dataset. An image classifier trained on millions of objects can be fine-tuned to recognize medical X-rays with just a few hundred examples. A language model like GPT, that has read the internet, can be fine-tuned to analyze legal documents, medical research, or poetry with minimal new data. This drastically reduces the time, cost, and data needed to train high-performance AI. Real-world applications. How transfer learning is changing AI. 1. Medical diagnostics. AI that learns from general to specific. One of the most life-changing applications of transfer learning is in medical imaging. AI models trained on general image datasets, like ImageNet, learn basic vision skills, edges, textures, shapes. These models are fine-tuned on smaller datasets of MRI scans, CT scans, or X-rays to diagnose diseases like cancer, pneumonia, and brain tumors. This means doctors can deploy highly accurate AI diagnostics without needing massive labeled medical datasets, something that was previously impossible. 2. Language translation. From general speech to specialized jargon. Language models like Google Translate and GPT use transfer learning to adapt across languages and disciplines. A model first learns basic linguistic structures from billions of sentences. Then, it is fine-tuned on medical, legal, or technical documents, enabling it to provide expert-level translations in specialized fields. This allows AI to bridge language gaps in industries where accuracy is critical, like medicine and international law. 3. Facial recognition. AI that learns to see faces faster. Facial recognition models don't need to be trained from zero for every application. A general face detection model, trained on millions of images, can be fine-tuned to recognize specific individuals or demographics with just a small dataset. This is used in smartphones, security systems, and forensic investigations. 4. Self-driving cars. AI that adapts to new environments. Self-driving cars use transfer learning to adapt to different driving conditions without needing millions of new training examples. A car trained to drive in California can be fine-tuned to handle snowy roads in Sweden by feeding it a smaller dataset of winter conditions. This enables autonomous vehicles to generalize and improve efficiency across the globe. Why transfer learning is a game changer. Before transfer learning, AI was stuck in a one model per task paradigm, where every new challenge required massive retraining. Now, AI can learn faster, cutting training time from months to hours, use less data, reducing the need for massive labeled datasets, be more adaptable, applying knowledge across industries with minimal fine-tuning. This is why large pre-trained models like GPT, ResNet, and BERT have become the foundation of modern AI. Instead of thousands of small, specialized models, AI research now focuses on building massive general-purpose models that can be adapted through transfer learning. The future of transfer learning. AI that evolves like humans. Where is transfer learning headed next? Self-learning AI, models that fine-tune themselves based on experience, without needing human-labeled datasets. Multimodal learning. AI that transfers knowledge between different types of data, like text-to-image generation, DALL-E, or audio-to-video synthesis. Zero-shot learning. Future AI might require no fine-tuning at all, generalizing across entirely new tasks without additional training. We're moving toward an era where AI doesn't just learn from the past, it transfers that knowledge effortlessly, adapting to new challenges like never before. Transfer learning is the reason AI isn't stuck in the past. It's the reason AI can build on itself, learning, evolving, and becoming more intelligent with each new task. And as we refine this ability, AI will not only assist humans, it will learn like us, grow like us, and ultimately, think like us.